But this is what we did. I mean, last time we started by creating arrays, and we stopped in array initialization. I mean, the second part of it, and just we went into explaining the arrays and how to initialize them, how to put something, how to use this score.length. I mean, the .length thing, and this is where we stopped about talking about another way to initialize the arrays by putting the initial values directly. Okay, just quickly, an array, we said it's like some sort of a big box that has one name, and under that one name I can have a lot of smaller boxes when I can put a lot of different elements in it, which will allow me to have to solve the problems if I need to collect a lot of information and I don't need to declare many variables and indeed only use one name, and then I'm going to be able to, with that same name, having different places where to save those different elements in it. The only thing that you have to always bear in mind that if I declare this array to be of a data type, all the elements would be having the same data type. That means if it's double, all the elements inside should be double. I cannot have a mix of them. Well, as of now. Maybe later on we're going to learn how to do something different, but now for the scope of this course we're not going to be doing something like that. So if I do something like this, for example, if I'd like to put some initial value that I already have, there's a better way than just using this in a loop, for example, and then putting the values directly there, which might be, I mean, using a loop is not convenient if I know already the values. So there's something like this that I can do, which actually, if you compare it to the previous declaration that we did, which was something, let's say here, for example, when I specify actually the size, I'm specifying the data type, then the name of that array, and then the same data type I used again with the new before it, and then between those brackets I use the size of my array, which in this case 5, for example, which means I will have 5 elements in that array. So there's something that I can do when I'm doing something like this. When I directly put the values inside of the array, I don't need to specify the size, because the size is going to be determined by how many elements we have. So this is what's going to happen when we write something like this. I mean, we already have like this 5 elements, but again we need to remember that the first element is the element at the position 0, and the second position 1, the third position 2, and so on. So when I have 5 elements in an array, so the index of the last one is going to be 5 minus 1, always. So this is what you need to remember. So in this situation I will have 80 in the first part, 99.9 in the second element, third element, 75, and so on. Every element is going to go into the place that is going to be according to the position, that the sequence that I added. What happens if I do something like this? So what is the size of this array? The size of the array, I need to count how many numbers, how many values do we have? How many values do we have? So I have 1, 2, 3, 4, 5, 6, 7. That means the size of the array is 7, and then the index of the last element is 6, exactly. So because we start from 0 to 6. Okay. So that's pretty much about it. So in like the previous way, when we declared some arrays, we initialized when we created at the same time. But actually we can do something like this, for example, to declare the score of when I specify the size. However, when I'm using my values like the previous initialization, I cannot do something like this. Why? Because actually this will not work, because when I'm declaring I need to specify the size as well. So in this case I just declared that this can hold an array, but I didn't say what's the size of it. So before using it I need to specify the size. So that's why this way of specifying the size and putting the values inside of it, it would not work if I split it into 2 parts. But this one will work if I split it into 2 parts. It's okay, it's permissible. So this is what you should need to be careful about. Bounds checking is that something that we need to make be careful on when we specify the numbers between the brackets. We need to make sure that we put the numbers that exist in our in the range of possible indices. And if we don't, you're going to see this type of error message: array out of bound exception, array index out of bound exception. So if you program in an exercise and then you find that you have this error message, for you have to really understand that what does this mean is that you are using a number between the brackets that is not existing in the array. Let's take an example. For example, I have this array of size from 0 to 4. If I write something like this, it's okay because 3 exists, are going to be invalid index. What about something now that is like this? Well, if you write it down, if you type it on NetBeans or JCreator or any IDE, it will not tell you, you have a mistake. It will just let you write whatever you want, but this is a syntax error. No, there's no syntax errors. You wrote everything correctly. But this is something that is not possible because when it tries to run, when you try to run, then it will give you this array index out of bound exception because there's no box number 7. Well, if you want that box number 7, you should declare it at least to be 8. Very good. It should be 8 because if it's 7, the last box will be number 6. Yes.
Why score bracket 1 and inside the out system out
like this? You mean this between parentheses you put the system.out print line? Yes. If you'd like to print the content of the box number 1, yes, of the element 1 of this score. I think we don't call them boxes, we call them elements. And these are not box numbers, but these are indices. So if I'm saying the index of an array, you know that I'm talking about the numbers of those boxes. If I'm saying the elements, I mean the what's inside the box, that's the element. What's inside of those. So that's what it should be. I mean, you should always be careful to not get those mistakes, and don't get confused also. You remember we've seen this off by 1 error when we'd like to make those loops and we'd like to count or repeat a specific number of times. If we don't pay attention, we might be not repeating the number of times we want. Take a look at this example. What's wrong with it? Or is it wrong? I like it when everyone starts to talk at the same time. That's wonderful. So you said?
Less than S.length.
You mean this one
Yes.
is a problem?
Yes.
Sure.
Yeah.
Why is that?
5 number from the beginning from 0.
First of all, what this s.length means? What is this? This is the length of the array. How many values, how many elements in the array? That's 5. So this is going to become 5, right? Okay, very good. And what's the problem with this equal sign? So I should not be equal to 5?
No, it's 5 unless 5 unless.
It should be 5 unless. That means it should be 5. It can be 5. So the equal sign should be there.
5, 6 number. 0, 1, 2, 3, 4, 5, 6. 6 number 5. 0, 1, 2, 3, 4, 5, 6. 6 number.
So what you're saying is that if I include the 5, I'm going to have to repeat here 6 times, not 5 times.
Yeah, then change 5 to 6.
And I need to change 5 to 6. If I need to change 5 to 6, then I need to change 5 to 6 from here. So then there's the problem. So this is what both of you're right. The problem is that if I leave it like this, for I will be 0, which is okay. S0, that's no problem. S1, no problem. S2, S3, S4, S5. But there's no S5 because of this, the box. Well, we're not talking about Galaxy phones. It can go up to S6 or maybe S7 is coming. But now I'm talking about this array 0, 1, 2, 3, and 4. We have 5 elements. This is what we declared. So this is our S. So S5, where is S5? There is no S5. So if I keep this equal sign, it is going to give me an array index out of bound exception. And you're right, I need to remove this so I don't get to be above my limit. My limit should be length minus 1, so it should not be length exactly. That's why I'm not putting the equal sign.
Can I put length minus 1?
If you put the equal sign, yes, you can put then s length minus 1. Yeah, good option. However, it's better not to have that because it's an extra operation that you can avoid. Because this question is going to be repeated 5 times, and then you're going to repeat this subtraction 5 times. While if you just remove this, and then you saved 5 different operations. So that's the thing. You have to be careful and just make sure that you count things correctly. And if you do something like this, for example, you're going to have this array index out of bound because of that equal sign. Okay, some things that might be a bit interesting. If I'd like to display something from an array, this is generally the code that I need to do. Imagine that I have my array, and this is the general code that I need to most probably always use. This one over here. Maybe let's just erase them. This one is like some sort of a generic code, depending on you might change the name of your array to any array that you used, but this will work with any size of your array, with any value of your array, because it is going to depend. If it's int and then the name of your array is something else, you're going to put something else, and then depending on the size, it's going to be working regardless of how many items you have there. It's going to read them all from 0 to the last one, which is length minus 1, and then display it. However, if you'd like to display the array and you think you just put the array name there between parentheses and thinking, oh, why do this for loop? Just go ahead and put the name between parentheses. I'm going to display the whole array. No, it will not display the whole array. It will display some weird thing. Probably it should be interesting to see it working. So let's let NetBeans show you the result. Actually, what happens before we can see the result? What happens is that if you do this score now is not like a simple variable that you can just display as you display any int or any double. This is an array of doubles. So it's a lot of different doubles. So if you put you'd like to display score itself, it will display an address. So we can understand actually what the result is going to give us. It's going to display an address of what? Well, actually, if you noticed, every time we were talking about these arrays and we're representing them with something like this, a score that points to something, because this is how it works. Actually, it's some sort of a pointer. It points to something, but this is an address to some place in the memory where it shows you where the array starts. It doesn't show you the whole array. So that's the thing. So let's have a look at how it looks in here. NetBeans. Let's try just use this. No. Close all of them because I had some file that I created that called it intro 4. I'll just put something in here and remove this. Let's just declare an array the same way we declared the double score equal, and I'm going to put like 1, 2, 4, 5, whatever. So, and let's display this score I. I'm putting a space because I'm going to display them one next to the other, and just to see this working first, keep one. Let's run this, and so I can see the 1, 2, 4, 5 being displayed, and then I'm going to display 2, 4, 5. Why 2, 4, 5? Yeah, because look, I didn't do my things right. I need to make sure that I always use this score.length, and I'm not using the equal sign because I don't want it to be used. So this is starting from 0 and less than the length. This is what I need to do, and now it seems to be, inshallah, okay. 1, 2, 4, 5. Okay, and it's all 0.0 because it's all double. If I make them int and then I display them, go back to the line, so I'm not having this build successful next to it. And now this is my array. Okay, now this do something different. Instead of, okay, I don't want to do all this, let me just display the score like at the beginning, just the score itself. So now I'm displaying the whole score, print back and go back to the line. What about that? What is this? Well, that's something that looks like an address. This is an hexadecimal number that says that this is a place in the memory. Is it meaningful? No, but just if you do this, this is what you get. You get something which is not what you want. So if you want to display, the array, you have to go through a for loop, one by one.
Does the address change at every?
That's a good point. Maybe if I'm just using this run after another, maybe it's just not going to be changing that much. But after a while, it might change. Because now this is the closest available one, so it's always going to give me that one. But if I open a lot of different applications, maybe it's going to be different. I never tried though. You can try. That's a good experiment. But logically, this is what should happen. Okay, so this is what we were talking about. So this is the thing. Okay, let's have a look at some other interesting ways how to work with arrays. And this is the part when we were talking about this array processing. There are different things that I can do with arrays because I'm storing large numbers, a large number of numbers of elements. I can do a lot of things with those numbers. I can find what's the maximum, what is the minimum. I can sort them from the smallest to the largest, or the opposite, from the largest to the smallest. I can do a lot of things with those numbers. And one of the things that are interesting to do is to find the maximum. And this is one way to find the maximum. Actually, what it does, it just not only finds the maximum, it finds also the position of the maximum. So you have an array, you have a lot of numbers, it finds which one is the greatest, the largest, and it tells you which part of the array this one was found. And let's find out how it works. Oh, let's keep using that. So we have double score. This is our array. So what's the size of that array? 5. So from 0 to 4. And then I'm starting, look at here, I'm starting from I equal to 1. Why is that? Because I have max. I have the max, this is a variable, and put 0 inside of it. Why is it 0? Actually, it starts from 0 because, they assume that all the numbers are bigger than 0, so they put in 0 because we know that all the numbers are going to be greater than 0. So we're going to we put a number just to be the smallest, so we can find a bigger one. If I put like 1000 as the maximum, do you think that I'm going to find the maximum? No, because I already know that this is my max. And actually, no, this is not the percentage. This is not how you should look at it. Because this max here is not the maximum value, but this is the position of the maximum value. Don't look at this number as like to compare to those numbers. But look at this number as, where is my maximum? And I put 0, that means I'm assuming that this is my maximum.
Because you put the max inside the score.
Exactly, because look at how I use max. This max is not used, I'm not putting a number inside of it, I'm using it as a value. And by the way, inside here, if you would like to use an index, a variable as an index, like here, those variables have to be int. You cannot declare them as double or float, or it has to be int. So if you look at here, what I'm doing, I have now these two variables. I have max and I have I. The first thing I say, max is 0, which means I'm assuming that the first one is the maximum. And then what I do, I start with 1. That's why I'm starting with 1 with I. So I is equal to 1. And then I'm comparing score of I. What is score of I?
99.9.
This is score of I. because this is 0, this is 1. Is score of I the score of 1? Is this greater than score of 0? In other terms, is 99.9 less greater than 80?
Yes. Yes.
It is. So in this case, what should happen?
The max is, you put, oh, okay, switch stuff on.
I'm not switching. I'm just taking what is inside of I, putting in max.
Yeah.
What's the result of that?
99,
What would be inside of max now?
99.9.
No, that's not what's inside of max. Put whatever is inside of I, max. So this is 1. So inside here it's going to become 1. So now I'm saying, I was thinking that the first one was my maximum. Now I found that there's another one which is a maximum. Let's make it the maximum. And then I finish the if. I go up. When I go up, the first thing that I should do is
Start the I is equal to 2.
I plus plus. So now I becomes 2. And I'm asking, is 2 less than 5? This is 5, right? 1, 2, 3, 4, 5. So I'm asking, is it 2 less than 5? Yes. Score of 2. What is score of 2?
75.
So 75. Is it greater than score of max?
No.
Score of 1? Is it greater than 99.9? No. So I'm not going inside. I go up. I becomes 3. Is 3 less than 5? Yes. Now what is inside of score of 3? Score of 3, this is 100. Now is 100 greater than score of max? This is score of max. Yes. So 100 greater than 99.9. So what would happen is that now max becomes
Equal to 3. That's not so bad.
becomes 3. And then finished, go up. I becomes 4. Is 4 less than 5? Yes. Is score 4? What is score 4? Is 85 greater than score 3? This is score 3. Is this greater than this? No, so I'm not doing anything. What's next? It becomes 5. Is I 5? Is 5 less than 5? No, we get out. We display the maximum is at index max. What is max? 3. It is score max. What is score max? So I'm finding the maximum not by looking at the value and just remembering the values. I remember the position, and if I get the position, I get the value. So that's the idea on how we can find a maximum or a minimum. Yeah.
If we wrote 4 int I equals to 1,
Yes.
I less than score length, then I plus minus minus.
Okay. If int I equal 1, then in the condition stays the same.
Or 5 equal.
I greater or lesser? What do you?
Start from right to left.
Then you should not start with 1. If you would like to start from right to left, you should start with 4 then. So you start with, or maybe score minus 1.
So we can flip it.
You can flip it, no problems. You can start from score minus 1 here, and I greater or equal to 0, because you want it to be equal to 0, and I minus minus. And then it's keep the rent, everything is going to be the same. Except that instead of starting from 0, you should probably start from here. So you can start from left to right to left. Yeah, you just need to put your conditions thing. The first thing is you start somewhere. You assume that the maximum is one of them. You take one of those and you say, okay, I'm saying this is the maximum, and I'm going to compare with the rest. If it's really the maximum, it will stay the maximum. For example, if it was like 800. So is this one greater than this one? No. This one greater than this one? No, no, no. So it will stay the maximum. So that's how it works. And this is a visual representation of it. I should have used it actually. But just to summarize, we start by assuming that the maximum is the first one, because this is our maximum is the position. And then I start with the loop. I put one in I, and then I compare them. Is this greater than that? Yes, in this case, because 99 is greater than 80. So I move, my maximum becomes now the I, and then I becomes 2. And then I keep doing the same thing. When I find the bigger one, I just move the max to that position. And when I'm done, I end up with the position of the maximum. Actually, at the end, I is equal to 5. Another thing that we can do with arrays is looking for a specific value if it exists in an array or not. And this is something interesting because this is probably the first time when you have an example when we are going to be using booleans, because we said we'd like to know if a value exists or not. So the answer is either true or false. So let's have an idea on how to do that. And this is one way on how to do it. There are other ways probably, but this is one of the ways. So what we do is that we're trying to look for a value. So let's say we're looking for 75. And we're going to be, if you notice, always the same. If you would like to go through all elements of an array, there's always for int I equals 0, I less than score dot length, or any array name dot length, I plus plus, and then whatever it's inside is what you need to be thinking about. And then notice that I'm declaring a variable called found and making it boolean. So that means inside the variable I can only put true or false. And true and false are different values. That, like 1, 2, 5 are values for int, while true and false are values for boolean. Yes?
I think this question just showed that 75 exists, but just why we just type it with false, not true.
Well, let's find out. We assume that we don't find it, and then we look for it. If we find it, then we say it's true. We can do something similar, but then we start with true, and then I need to change my code in that situation. I'm assuming that I found it, but if I go through and I didn't find it, I need to say I didn't find it. So the easiest way is to go with the false, because this is, I assume that I didn't find it, and I put some ifs, and if I find it, I put it true, so it's easier than the opposite. Because if you put it as true, how do you know that you didn't find it? You have to make sure that some other ways into to find in that. You might put a counter, you count how many times you repeat. If you repeat this same number of times, maybe. Anyways, it's it's less natural to use that. But it's possible, you can do that, no problems. Yes, so we assume that we put found as false, and then what we do, we check each one of the elements, and if one of them is equal to that number, I just put this at true, and then, remember this? Break, which means stop the loop. I'm getting out of the loop. That means the next thing that would happen, I will go here. And then because found, if it was found, it's going to break and then go here. And this is if found. This is true. Yes, I'm going to say exist. But if, for example, I was looking for 175, it will never break, right? So it will start here, it will repeat 5 times until it will never enter inside of the if. So this found will never be true, because I will never execute this line. If I'm saying that I'm assuming that I'm looking for 175 instead of just 175, just of 75. If I'm looking for 175, there's no 175 here. So the answer to this question is going to be false for 0, false, 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 false 5 times. So I'm not going to go inside here. And if I finish all my 4, the next thing I come here, I ask, is found true? Well, found is false. So I'm going to go in the else and say not exist. So this is how we can look for a value, if it exists or not in an array, or as we've seen, like the maximum or the minimum of that in an array. Any questions regarding this? Easy to get? If you say easy, you're going to pay it, because you're going to show me how to do it later on.
The loop will never break until it's on the value that, like, until it's true, right?
Yes. What happens then if you really understand? What happens if I remove through this break? Will it still work?
It's gonna break.
It will still work? It will work, but it will continue. And yes, so what's the advantage of having break there? So, exactly, stop. We don't need to look anymore. We found it. So why keep looking? Imagine the array has 100 or 1000 values and you found it on the first 3. Why keep looking on the other 900 or whatever, 90 something? If you put system.exit, well, if you put system.exit, that does something different. What does this exit do? Remember? The program, the whole program. So the program will stop. You'll never see this. You never see exist or not exist. It will stop right away. Generally, we don't use this system.exit unless we want the program to finish. So.
We have 275.
Yes.
Value of 75.
Okay, good point.
And I wanna how many 75 and this value.
Okay, that's a good exercise. Thanks for the idea. I'm going to ask you that then. If you have like many 75s, not only one. In this case, I have only one, right? So I'm just looking for the first one and then I stop. If there were 2 75s, even if there's a 75 here, well, I don't care, because the question here is we would like to find if 75 exists. We don't want to know how many of them exist. But now if you would like to change the question, and then make it like, we would like to write a code to count how many 75s we have, right? So how to do that? Very simple, because now I'm not looking for found true or false, and I'm not going to remove this. And instead of having a boolean, I will have a counter. I'll put an int and a counter. I put 0. And if it was equal, counter plus plus. Inside here, C++, that's counter plus plus. Every time I get inside and I find a 75, I increment this counter to 1 by 1. So it was 0, so if I never find anything, it will display 0. If I find 1, it will display 1. How many times I found, it will just calculate how many times I found them. So it's not that difficult. All right, and this is how it works, just to summarize. We start with the I is equal to 0, and then we compare the score of I if it's equal to whatever we want. If it's the case, well, we get inside, but it's not the case, for example, here. So we continue. I becomes this, so it's not the case. I becomes 2, and then when I becomes 2, score of I is equal to 75. So we get inside, the found becomes true, and then we break. That means we get out of the loop and we come back here. Something interesting, and if you'd like to work with those arrays, is that what happens if I put one array inside of the other one? Like this. I'm declaring score 1 and I'm putting the values. I'm declaring score 2 and it doesn't specify the size, and I have not put any values inside of it.
It will have the same values maybe.
So we will be having the same values. Is it going to be copying?
Yes.
No. Sorry to disappoint you. But actually what it does, because these are not normal variables, these are special variables because they are pointers to something. If I declare something like this, it's as if I have another pointer to the same array. In other words, if I do something like, something like score 2 at 0, put inside of it 0. Which one will change? This one. But then if I display system.out.print score 1, 0, score 1, 0, what should I see on the screen? No, 0. Because it's like the same place, but you have two ways how to get to it. Same values, but two different ways how to go to them. If you'd like to copy for arrays, this is not how you should do it. This is how you should do it. Array cloning. This is how to copy. So one of them is to use this method, score1.clone, make a copy of it. Now these are like two separate set of values. So if you make change to one, the other one is not affected because they are completely separate. So this is if you'd like to make a copy of an array to another one. Don't use just score1 equals score2 or score2 equals score1. You have to put score1.clone and then you put it wherever you want. So like score1 we have .length. Now you know that there's .clone. Actually there's a lot of stuff in score when you use score dot. Maybe here. You have a lot of things. You have .length, clone, equals, get class, toString, notify, wait, a lot of different things. Well, we're not going to be seeing them all, but so now we know length and clone, how to copy. So I was saying to test if two arrays are equal, there's some things that I need to do. And first of all, I need to check if they have the same size, because if they're not the same size, they're not going to be equal. So first thing, if I'd like to test if two arrays are the same, I need to check first if they have the same size. That's why this is some code that will help me find out if this is if two arrays are equal. So imagine I have score1 and score2. I'd like to find out if these two are equal or not. I'm going to use this are equal, some sort of a variable that is Boolean, and I'm assuming that they're equal. And this is another way. This time they start by assuming they're equal. We can do the opposite, but anyways. But they say now is assuming that they're equal, and then I'm asking: is the length of the first one is different from the length of the second one? If they are different, then are equal becomes false. Actually, this is only everything in one line. It's just the response of the false of the if. Else, if this is not different, that means they're equal. So they have the same size. If they have the same size, so I'm going to check if they are equal. Each value. So what I'm doing, I'm looking for the value from 0 to score1.length, anyways, and then I'm checking the value of the score1. If it's different from the score2, I put are equal to false, and I break, because I know no need to find out, just they're not the same, so I can get out. So they have to have the same values on all the elements in order for me to be able to say that they are equal. And then if one of them is different, then I get out, and I know that here I can do something. If are equal is true, then display they are equal, else display they are not equal. And this is something that is used to compare with this equals. Sometimes we need to change that. Maybe we are going to be talking about this when we talk about classes, which is maybe in 2 weeks. We're going to start talking about classes and how to create our own classes and everything. But just know this is how to make this comparison between two arrays. If I'd like to know if they are equal or not, I need to first compare if they have the same size, and then if they have the same size, I need to check the values one by one. And this is how we do it with for, and then we check every value and compare it to the other one. Notice it's the same I that I'm comparing. That means score1 of 0 should be equal to score1 of 0, score2 of 0. Score1 of 2 should be equal to score1 of 2. So each one of them should be equal to the counterpart. And I can just do the same thing with this equals. We can override that. I mean, as I said, we can maybe something that we might see later on, but we can just do something like this. Score1 dot equals score2. So generally, if I do this, I mean, it should tell me if they're the same. So for example, if I do something like this, and I display, let's say, score s1 dot equals s2, and I'm displaying this on the screen, that means I should see what? Either true or false. What do you think? Should I see true or false? Are they equal?
Yes,
Because we changed the zero.
Because I changed one of them. Now if I just remove this change and run it again, and I have no idea why. I don't know. No, if I remove the clone, obviously it's not going to be the same, but now it's with the clone. I just removed this change and it keeps saying this, and I don't know why.
Remove the comma.
You know what? Actually, I know why. Because what it's doing when I do this s1.equals, it is not comparing like what we did here. Because the way now this thing works is that we made some sort of rules in order to compare two arrays. But the equals that is implemented there, it just works in a different way that you expect. Actually, it works in a way that if I remove, for example, the clone, you remember what does this do? Actually, S1 and S2, both of them point to the same place, right? This is what we've seen before. Now, if I leave it this way and ask if they're equal, it's going to be true. Which means this one is pointing to the same one. This is what this dot equal means. Is this exactly the same array? Not a copy of it. The same one. That's the equals. If I make a copy, then it's going to tell me, well, even if I don't make any change, it's going to tell me, I don't need this one. It is going to tell me, well, they are not the same because this is a copy of another one. They have different addresses. Yes. Excuse me? I told you to remove the clone?
Yeah, to show it, yeah. To show it's
They're equal. It's true.
yeah, so but I don't know the reason.
You don't understand why?
Yes.
Okay. Let me maybe clarify this. Why is this different? How to do that? Maybe look here. Oops. No. Let me have my whiteboard. So we had S1, right? In this S1 was pointing to this array that has some, let's say, some values here and some values here. Let's put, for example, 0 and 1. And then I had another S2. If I put S2 is equal to S1, what happens is that I'm just adding another S2 that points to the same place, the same array. So if I'm asking, is S1 equals S2? Yes, because these are the same. But when I use clone, now when I'm using clone, so it will create another one. Dot clone. I don't know if you're going to be able to write it with the mouse. Yes. Anyways, imagine that this is clone. So now what's going to happen, it is going to make another copy, another 0, another 1, and have this S2 pointing to this place over here. So now my equation is S1 equals S2? No. Because it does not look at, do they have the same size, do they have the same content? It works on a different level. This equals, just have a look at the same address. Are they the same address or not? If they are the same address, they say true. Not the same address, it says false. This is how these equals work. Yes?
I mean, if we use clone, we need, if we want to make sure it's equal or not, we need to use the first way.
Exactly. We need to use this code over here. If you'd like to compare, even with, I mean, if they are equal or not, two arrays, after we do the clone, we need to go through using this method over here. We cannot just rely on, oh, there's equals, let's use it.
This is for same address.
Yes, if we have the same address, same objects, yeah.